Okay, these are your notes for section 4.1, storing data in matrices. Here's your journal choice. If this is an interesting choice for you, please feel free to write about it. Objective and what's the point? We're going to learn a lot of vocabulary today about matrices. There's a whole branch of mathematics that studies matrices. It's called linear algebra. If you are going to be a math major or engineer or any of those math type careers, you'll probably have to take the class. It was one of my favorite classes that I took in college. We are going to write matrices for points and polygons today. We're going to use matrices to store data. This is really important because you have to organize data a lot, and this is one way to do so. Where's to know? What is a matrix? It's a rectangular arrangement of objects or numbers. Here's what a matrix looks like. A lot of times you see square matrices, 1, -4, maybe we'll put an X in there, and a pi sign. Well, here we go. It has square, what are these called? Square brackets, I guess. It doesn't have to be a square, but a lot of times they are. It could be any rectangle under the sun. It could be all the same numbers. These are all both matrices. There's one down here also. An element is one piece. So this whole thing is a matrix. This is an element. Element, element, element. So this one has 6 elements. This one has 4. This one has 2. And we say it's each object in a matrix. The dimensions is what the size is, okay? This one is pretty obvious. This is a 2 by 2 matrix, okay? But this one is not as obvious. So this is what I wanted to look at with you. You give your rows first and columns. Think RC Cola. And so we go rows by columns. And I'm going to tell you this is going to be sad for you. And I am angry at all elementary teachers that have ever taught because they have damaged my students. When you guys are in elementary school, they have you set up in your seats and then they dismiss you to go line up for your lunch ticket or whatever you're doing. And they say, row 1, go up to the board. Well, this is going to blow your mind. This is very sad. They should have said column 1. Okay? This is what you need to remember. Columns hold up buildings. This is a column. This is a column. And I feel like our elementary teachers told us those were rows. These are rows. Here, I can write C for column. These are rows. See? Rows go this way. And the way we get the size is rows by columns, RC equal, like I said. So this would be a 3 by 2. And it is important that you know these because these will show up on tests and quizzes and just in general communication. If someone's telling you the size of a matrix, you need to know which direction it is because a matrix that looks like that is very different than one that looks like this. And that's a 2 by 3. Okay, so be really careful whenever you're expressing the dimension of a matrix. What are equal matrices? Equal matrices are matrices that have the exact same dimensions and the elements are equal. So I'll go to here, xy is equal to xy. Same size, same elements. Okay, and the last word we're going to talk about is a point matrix. And a point matrix is a way to hold ordered pairs, and we put the x coordinates on top and the y coordinates on bottom. Alright, so here is an example of a way we can use a matrix to organize data. In the fall of 2008, math classes at a local community college had a total enrollment of 2,850 compared to 2,241 in the fall. Additionally, English classes had blah blah blah. Biology classes had blah blah blah, and psychology classes had blah blah blah. They wanted to arrange the data into a matrix representing years as rows, okay? If you were going to organize this, if I just gave this to you, a lot of you might go to a computer and use a spreadsheet. Very similar here, okay? And a spreadsheet actually is an example of a matrix, except they don't have the, what do we say they're called? Brackets in place. But it's just really a fancy table, okay? Or a non-fancy table for that matter. So we're going to arrange this, and they want years as the rows. Remember, rows go left to right. So what are the 2 years we're talking about? It looks like 2007 and 2008. And We are talking about math classes. I'm going to go up here because I don't want to run into the words. English, bio, and psychology. PSYCH. Okay. So let's look here. In 2007, what was the math numbers? 2241. And in 2008, it was 2850. Just filling in this table here. English, we had 2620. Are we going 2008 first, then 2007? So 2620 and 2051. Biology, 1572. 1160. 740. I think I have them wrong. 784. Let's look here. Math, 2850, 2008, 2241, and 2007. So we're always going 2008, 2007, 2008. Yeah, this is the one that's backwards. 1160. 1572. Okay. So this is a matrix representing this information, and the years are in rows. What would it look like if the years were in columns? I'm going to go with white here. And just kind of be flipped on its side. Oh, that white doesn't show up on the pink. 07, 08. So now the years are columns, and I'm just going to use M for math, English, biology, psychology. Math, 2007, 2241. Math, 2008, 2850. It is very easy to go back and forth here. English, 07, 2051. English, 08, 2620. 07, biology, 1572. 1160. 784. And 740. Okay, like any spreadsheet, the reason these are so helpful is because you can make some comparisons. You say, well, it looks like the math numbers are growing up, English is going up, but the biology and psychology are going down a little bit. Should you be alarmed? What should we do? Where should we put money if we're trying to recruit students? And so on. Okay, so it's just a helpful way to organize data. Okay, this is a point matrix, and we are going to plot by hand this point matrix. Remember, X is on top, Y is on bottom. So basically, this is just representing the order pairs: 3, -5, 6, -1, 4, 5, -5, -0.75, and -2.54. A lot of my students write almost, they like to write their order pairs this way. This is a very easy way to organize it. We usually will say, if it's written this way, that it will be a polygon. We're going to go ahead and connect this last point to the first point to make it a polygon. Let's look what we have here. A is at 3, -5. Okay, so there's A. B is at 6, -1. C is at 4, 5. E is at -5, -0.75, so maybe right out here. And D, oh, I should have been going in the order here. A to B, B to C. Oh, that was bad. Pretend that was good. C, D. And where's D at? -2.5, up 4. I bet that was a typo. This can't be a polygon, can it? Because then that would be D. And then to connect it would not make it a polygon. So let's assume that these 2 points were in reverse. because if I wanted you to make this a polygon, it would have to be. So we're taking some liberties with this problem because a lot of times one of the objectives it said was to use it to represent a polygon, and the way it was written is not. So this is a polygon now. And what kind of polygon is it? It looks like a pentagon. Go cards. Okay, so this is an easy way to represent data. It looks a lot like your spreadsheets on your table on your graphic calculators, except it is on its side. But you could flip it if it helped you. However, all point matrices are going to be horizontal and not vertical. Okay. Fill in the blanks. This equal sign is very powerful. When two matrices are equal, they're saying they're going to have the same dimensions. They're both 2 by 2, and that the elements have to be equal. So you notice -6 equals -6. 1/2 is 1/2. So what does R have to equal? 4.3. And what does W have to equal? 0.9. All because of that equal sign. They tell us each element will be equal. Okay. Tonight's homework, which I'll tell you tomorrow. And this is the Matrix. Get it? I don't know if you've heard of that movie. I've actually never seen it, but that's what I got. All right. Till tomorrow. Goodbye.